Okay, Assalamualaikum warahmatullahi wabarakatuh, and a very good day to everyone. Okay, so welcome back to our class. So today we're going to continue our lesson with 9.2 acceleration. Okay, so for this subtopic, there are few learning standard that we are going to go through. Okay, so let's look at the first one. Okay, so this is the first one. Okay, so we're going to explain the meaning of acceleration and deceleration as a rate involving speed and time. Okay, so let's look over here. Okay, so there are runner over here, sprinter. Okay, so sekarang suka Olimpik kan, ada tengok tak dekat TV kan, suka Olimpik, orang berlari laju. Okay, so itu kita boleh kaitkan dengan acceleration and deceleration. Okay, so let's look over here. Okay, sprinters begin a race at the starting line. Okay, once the race begins, okay, their speed will increase as they sprint towards the finishing line. The increase in speed results in acceleration. Okay, after they have passed the finishing line, they will slow down. The decrease in speed results in deceleration. Okay, boleh faham Okay. The change of speed can be calculated by finding the difference between the final speed and the initial speed of a linear moving object. Okay, from the activity, the increase in speed results in acceleration and decrease in speed result in deceleration. Okay, therefore, acceleration and deceleration is a rate involving speed and time. Okay, so let's look at the first example. Okay, before that, let's look over here. Attention. Okay, the stationary state, okay, bila satu benda itu pegun tidak bergerak, okay, is the fixed state of an object. Okay, so the speed is 0. Okay, stationary ni maksud dia pegunlah tidak bergerak. Okay, so example 13. Okay, a racing car accelerates from a stationary state and reaches a speed of 1 to 0 km per hour in 6 seconds. Okay, calculate deceleration. Okay, so what can we do first? Okay, we need to find the change of speed. Okay, so you can write change of speed. Okay, the change of speed is, okay, kita ambil laju akhir tolak laju awal. Okay, so the final speed minus the initial speed. Okay, so the final speed, okay, we know is 120 km per hour. Okay, minus with the initial speed. Initial speed is, okay, based on this one. Okay, the initial speed is stationary state, right? We know the stationary state is speed equals to 0. Okay, so initial speed is 0 km per hour. Okay, so the change of speed is 120 km per hour. Okay, so now the question want to find acceleration. Okay, before that, okay, we need to change the unit. Okay, okay, so now we have, okay, 100 kilometer in 1 hour. Okay, now, okay, we need to change, okay, this hour into second. Okay, because the question is in second. Okay, so let's convert. Okay, so we have 120 kilometer. Okay, so we know that, okay, in 1 hour, okay, we have how many minutes? So we have 60 minutes. Okay, and in 60 minutes, Okay, we convert it into second. Okay, so in 1 minute we have 60 seconds. Okay, so press your calculator. 120, okay, divide by 60 times 60. Okay, we will get 0.033 kilometer per second. Okay, so now we want to find the acceleration. Okay, so acceleration, okay, we have 0.033 kilometer per second. Okay, then we divide with how many seconds? 6 seconds. So divide by 6 seconds. Okay, and our answer is 0.0056 kilometer per second square. Okay, so that is how you calculate the acceleration. Okay, let's look at number 14. Okay, example 14. Okay, a motorcycle moves from a stationary state and accelerate uniformly to reach a speed of 20 meter per second in 5 seconds. Okay, what is the speed of the motorcycles? Okay, so over here the unit is meter per second in 5 seconds. Okay, so we don't have any problem. We don't have to change any unit. Okay, like number 13. Okay, over here in the question it given 120 km per hour in 6 seconds. Okay, to make it easier for us, that's why we change this hour into second. This one. Okay, it's actually to make easier for us to calculate. Okay, so let's look at example 14. Okay, so we can calculate the acceleration. Okay, so we know that the acceleration is, okay, final speed is 20, okay, minus initial speed, which is 0, divide by time, okay, 5 seconds. Okay, so we have 20 divided by 5 is 4 meter per second square. So this is the unit for acceleration. Okay, okay, next we have, okay, okay, after the motorcyclist applies the brake, okay, the motorcycle moves slower at a uniform rate until it stops within 4 seconds. Okay, what is the speed of the motorcycles? Okay, so now let's calculate the acceleration. Okay, so acceleration, okay, so the final speed is 0 because the final speed it stop because the motorcycle stop. Okay, sebab tu final speed dia adalah kosong. Okay, minus initial speed kita tadi adalah 20 kan. Okay, then divide by in how many second? 4 second. Okay, so kira kita ada negative 20 divided by 4 is negative 5. Okay, meter per second square. Okay, so don't worry kalau jawapan kita negatif. Okay, this negative actually, okay, bermaksud dia semakin perlahan, decelerate. Okay, so we can say that, okay, the motorcycle, okay, deceleration is 5 meter per second square. Okay, di sini awak boleh tengoklah attention ni kan. Okay, dia dah cakap di sini, for deceleration the negative sign does not need to be written. Okay, acceleration negative 15 sama juga dengan deceleration equals to 5. Okay, okay, cuba tengok di sini. Okay, unit commonly used to measure acceleration. Okay, speed kilometer per hour. Okay, time unit adalah hour. Okay, acceleration unit biasanya kilometer per hour square or kilometer h kuasa negatif 2 ataupun kilometer per hour dua kali per hour, ataupun kita boleh gunakan meter per second. Okay, di sini time unit kita adalah second. Okay, you can write it as m over s square or ms power of negative 2, or you can write it as meter per second per second. Okay, lepas tu ada kuasa 2 sebab 2 kali per second. Okay, okay, next learning standard. Okay, we have perform calculation involving acceleration including unit conversion. Okay, now the question, okay, convert 4 to 0 meter per minute, okay, to kilometer per minute per minute. Okay, so macam mana kita nak buat? Okay, how to do this question? So first we have, okay, 4 to 0 meter, okay, per 1 minute, okay, and then per another 1 minute. Okay, so this is actually, okay, if you still remember, you've done it in Form 1, okay, or primary school, okay, the division of two fraction. Okay, for example, you have something like this. Okay, 1 over 2 divide by 1 over 2. Okay, how to calculate this? So you need to change it as 1 over 2, okay, times, okay, the denominator, okay, will become reciprocal, so 2 over 1. Okay, so you will apply the same thing in this situation. Okay, so we know that, okay, the denominator over here, okay, you have 1 minute, it's actually 1 minute over 1. Okay, so how can we change this? Okay, this is actually, okay, 420 minute divide by 1 minute, okay, times 1 over 1 minute. Okay, clear? Okay, so over here we have, okay, 420 meter. Okay, we change it to kilometer. Okay, so how to change meter to kilometer? Okay, so we have 420 meter. Okay, we need to divide 1000. Okay, and then divide by 1 minute times 1 over 1 minute. Okay, so you calculate the top part first. Okay, the numerator. So 420 divided by 1000. Okay, we have 0.42 kilometer. Okay, times 1 divide by, okay, over here we have minutes time minutes. Okay, when you have two things, okay, you multiply together. Okay, so we have minute square. Okay, so our final answer is 0.42 kilometer per minute square. Okay, so that is how you perform unit conversion. Okay, so if you have any problem with this unit conversion, okay, with this part, you can always rewind this part and repeat it. Okay, so next, okay, let's look at example 16. Okay, so we have Rani cycles for 3/4 of an hour from her home to the cultural festival held in the city with a speed change of 18 km per hour. Okay, traveling to the cultural festival takes 40% less time compared to the time for the return trip. Okay, at the same speed change, calculate the difference in acceleration between the trips to and from the cultural festival. Okay, so what can we do first? Okay, we need to calculate the acceleration. Okay, I'm going to zoom. Okay, acceleration. Okay, when Rani goes to the cultural festival, so I'm going to write as acceleration on going trip. Okay, so we have what is the speed change? So the speed is 18 km per hour. Okay, and then we divide it with how many hours? 3/4 of 1 hour. Okay, so you can write it as 3/4. Okay, or if you don't like fraction, you can write it as 0.75. Okay, no problem, you can write it. Okay, so press your calculator. 18 divided by 0.75, which gives you 24 km per hour square. Okay, this one is hour. Okay, so this is the acceleration when Rani go. Okay, and then okay, we know that over here it stated that the time when going back is 40% less, reduce. Okay, so we calculate the time reduce. So the time reduce, okay, is 40% less than the original time. So the original time is 0.75 hour. Okay, so press your calculator. 40/100 times 0.75. Okay, so we get 0.3 hours. Okay, 0.3 hour. Okay, and then okay, let's calculate the time taken for the return trip. Okay, so time taken for return. Okay, so the initial trip takes 0.75 hour. Okay, which is 45 minutes lah. Okay, so the time will reduce 0.3 hour. So we minus 0.3 hour. Okay, so 0.75 minus 0.3 is 0.45 hour. Okay, now we need to find the acceleration. Okay, acceleration during return trip. Okay, so we know that in the question has mentioned that the return trip same speed, the same speed change. So we have 18 km per hour. Okay, so write it as 18 km per hour. Okay, divide by the time. So the time for return trip is 0.45 hours. So write it at the denominator part. Okay, 0.45 hours. Okay, so then press your calculator. 18 divided by 0.45, which gives you 40 kilometer per hour square. Okay, then the question asks, calculate the difference in acceleration between the trips to and from. Okay, so we need to calculate the difference in acceleration. So we have 40 kilometer per hour square minus with the initial acceleration is 24. So minus with 24 kilometer per hour square. Okay, so 40 minus 24, we get 16 kilometer per hour square. Okay. Okay, next, let's look at example 17. Okay, so we have Sammy drove at the speed of 70 km per hour. He increased his speed to 100 km per hour in 30 minutes. Calculate the acceleration in kilometer per hour and kilometer per hour per second. Okay. Okay, so how to do this? Okay, so A. Okay, first we need to calculate the change of speed. Okay, so the change of speed, so we have the final speed is 100 kilometer per hour, okay, minus the initial speed is 70 kilometer per hour. Okay, so 100 minus 70 is 30 kilometer per hour. Okay, and then we can calculate the acceleration. Okay, acceleration. Okay, so acceleration is the change of speed is 30 kilometer per hour divided by how many minutes? Okay, the question, okay, 30 minutes. Okay, so divide by 30 minutes. Okay, before that, over here we see the question 1 per hour. Okay, so we know that 30 minutes in hour is 1/2 or 0.5. So you can write it as 0.5 hours because you know 30 minutes is 0.5 hours. So you straightly plug in 0.5 hours. Okay, it's easier for us to calculate. So press your calculator. 30 divided by 0.5, which gives you 60 kilometer per hour Okay, next B. Okay, B. Okay, B, it wants us to give our answer in kilometer per hour per second. Okay, so what we need to do first, we need to know 30 minutes, how many seconds. Okay, so we need to calculate that one first. Okay, so time. Okay, we have 30 minutes. Okay, so 30 minutes. Okay, in 1 minute we have 60 seconds. So 30 times 60 is 1800 seconds. Okay, then we can calculate. So the acceleration is 30 kilometer per hour divided by 1800 seconds. Okay, so press your calculator. 30 divided by 1800, 0.0167 kilometer per hour per seconds. Okay, if you want to give your answer in fraction also can, no problem. Okay, so you will have 1/60. Okay, the same thing. Okay, so that's it for example 17. Okay, so next, okay, so our next learning standard is solve problem involving acceleration. Okay, so let's look at this example. Okay, example 18. Okay, Lisna accelerates her car 4 km per hour per second while overtaking a car. If she has been driving at 100 km per hour, calculate her speed after 5 seconds. Okay, so let's understand this problem. Okay, so from the question, we know that, okay, the acceleration is, okay, while she's overtaking, okay, the acceleration is 4 km per hour per second. And then she began driving at 100 km per hour. Okay, the time we want to know is after 5 seconds. Okay, so calculate her speed after 5 seconds. Okay, the strategy over here, let's plan the strategy. So acceleration actually is the result of increase in speed. Where we know the increase in speed? Because we know that she's going to overtake a car. Okay, so let's implement our strategy. Okay, so from the question given, 4 km per hour, okay, is equals to, okay, this is the final speed minus initial speed. So we know that we actually don't know what is the what is the final speed. So we just write it as, okay, speed after 5 seconds minus initial speed 100 km per hour. Okay, divide by, okay, we know we want to find in terms of 5 seconds. Okay, so over here 5 seconds, we can move it to the other side, which gives us time 5 seconds. Okay, is equals to speed after 5 seconds. Okay, so over here, okay, I think it's forgot, minus 1 kilometer per hour. Okay, and then you can press your calculator, okay, which this one gives you 20 kilometer per hour. Okay, and then how to find the speed after 5 seconds? Okay, you need to move this minus 100 km per hour to the other side. Okay, so we have speed after 5 seconds is equals to 20 plus 100. So the answer is 120 km per hour. So the conclusion is, okay, the speed after 5 seconds is 120 km per hour. Okay. Next example. Okay, a motorcycle that moves at a speed of 40 km per hour decrease its speed by 20% of its beginning speed within 40 seconds. Okay, calculate the acceleration. Okay, so let's understand the problem. Okay, understanding the problem. Okay, so this motorcyclist begin riding at 40 km per hour. Okay, in 40 seconds. So the question wants us to calculate the acceleration. Okay, so let's plan the strategy. Okay, acceleration is the result of increase in speed. Okay, so let's implementing the strategy. Okay, we want to find the final speed. Okay, we know that. Okay, look over here. Okay, motorcycle decrease by 20 seconds, berkurang sebanyak 20. So kalau berkurang sebanyak 20, maksudnya 80 lah. Boleh? Okay, so 80 over 100 from 40 km per hour, okay, is actually 32 km per hour. Okay, so we know that this is the final speed setelah dia berkurang. Okay, so the acceleration is 32 minus 40. 32 ni tadi is the final speed minus initial speed. Okay, divide by in how many second? 40 second. Okay, and it will gives us the answer of negative 0.2 km per hour per second. So ingat, kalau ada negatif, kita buatlah conclusion. So deceleration is equals to 0.2 km per hour per second. Okay, so the conclusion is the motorcycle acceleration is negative 0.2 km per hour per second. Okay. Okay, next, okay, let's look at the last example. Okay, example 20. Okay, the diagram shows the speed time graph for the movement of a toy lorry in 27 seconds. Okay, the deceleration of the toy lorry is 0.741 meter per second square. Okay, A, calculate the speed V in meter per second. Okay, so the original one is in meter per second also, so no problem. Okay, B, calculate the distance covered by the toy lorry after 2.2 seconds. Okay, so let's understand this problem. Okay, so from the question we know that the acceleration is negative 0.741. Okay, why is over here negative? Because it was already mentioned that the deceleration. Okay, then the duration is 27 seconds. Okay, we need to calculate the speed, okay, for A, and then we need to calculate the distance after 2.2 seconds. Okay, so let's plan the strategy. Okay, we know that distance is equals to speed time multiples by times, and then speed is equals to deceleration times time. Okay, ini boleh ini pindah-pindah je. Okay. So next, implementing the strategy. Okay, so we know that this is the deceleration. Okay, betul. Deceleration. So deceleration, kita punya formula adalah final speed minus initial speed. Okay, dari sini ini initial lah, ini initial. Semakin turun, dia semakin slow. Okay, so 0 minus V. Kenapa 0? Why 0, sir? 0 because this is the final speed. Final speed is 0 because the lorry stopped. Okay, so 0 minus V in 27 second. Okay, next macam biasalah 27 kita pindah sebelah jadi darab. Okay, and then darabkan. So darab kita akan ni nanti kita akan dapat negatif kan. Okay, so 0.741 times 27. Okay, so it's actually will gives us negative 20 is equals to negative V. Okay, so V is equals to 20 meter per second. Boleh? Okay, next. Okay, this distance. Okay, distance is equals to speed times time. Okay. Okay, so the speed is 20 meter per second. Okay, from A kita dapat. And then the time is 2.2 second. Okay, so we get 44 meter. Okay, so saya harap awak ingatlah rumus rumus distance tu. Okay, from previous subtopic kan kita ada you have memorized this triangle D S M. Okay, so you want to find the distance, you cover D, okay, which gives you S times M. Okay, where S is speed, okay, M is time. Okay, so the conclusion is, okay, speed of toy lorry movement is 20 meter per second, and then the distance covered by the toy lorry is 44 meter. Okay, so that's it for subtopic 9.2 acceleration. Okay, so I want you to complete this question. Okay, question number 1, question number 2, question number 3, and question number 4. Okay, so that is your assignment for this week. Okay, so if you have any problem, you can comment down below, or you can just ask in the group. Okay, so I will answer over there. Okay, so that's it for chapter 9. Okay, so next week the first class, okay, I'm going to give you a short quiz on this chapter. Okay, so I hope you can study this weekend, okay, for the quiz next week. Okay, so that's all for today. Okay, thank you very much. Okay, thank you for your attention. Okay, see you next class.